Hello everyone, welcome to the channel. In this video we will learn about frustum of a cone. We already know what a cone is. Cone, the best example of cone is softy, the ice cream cone. Now if we cut the cone by a plane which is parallel to the base, like this is a cone and we cut it by a plane parallel to its base. Then the lower part of it, see here, we have seen with the diagram here. This is the lower part of it. This is known as the frustum of the cone. The upper part is a cone. Here we will find that the base, suppose having the radius R1, then the top of this also will be circular, and suppose the radius of this is R2. Where we find the frustum of a cone? The best example you are finding in your homes, that is the bucket. A glass, a steel glass like this, you can see this is a frustum of a cone. This is the upper part and this is the lower part of it. This is hollow of course, but if it is solid, then both the parts will be covered. Also we can see here, this thing we have learned with the demonstration of one of the cone. See, it is a cone we can see here. This is a cone you are finding. If I cut it from the height somewhere in between by a plane which is parallel to the base, then you will see this is a frustum of a cone. You can see it. The top is also circular and the base is circular. Here this is the upper part which is a smaller cone. So the frustum will be having two circular faces. They are with different radii because the radii of the top has to be smaller than this radii. So I think the frustum must be clear to you. Even the flower pots you are finding, some of the flower pots are in the form of a frustum. Now suppose this is a frustum, the radius of the base is R1 and the top is R2. If a perpendicular from E is drawn to this base like this, this is suppose point G, then will we find that GB is equal to R1 minus R2 or not? So this portion will be R1 minus R2. Suppose the slant height of this is L. Slant height is suppose L and we want to find out the length of the slant height. If the height of this is suppose H, then what we will see? This forms a right angle triangle. Then in a right triangle EGB, what we find by Pythagoras theorem? We find that EB square is equal to EG square plus GB square. What is EB? EB is L, that is the slant height. What is EG? EG is the height, H square here. GB, as we have seen, GB is R1 minus R2. So this will be square of R1 minus R2. It means we can find out the slant height of a frustum by using the formula L is equal to H square plus R1 minus R2 whole square. In case we are knowing the height of the frustum and the radii of both the ends are given to us. See, if you remember, in the cone we were finding L square was equal to H square plus R square. So what is the difference we are finding here? That in place of R square it is R1 minus R2 whole square. This way we can remember the formula easily to find out the slant height of a frustum. Now in case we want to find out the curved surface area of a frustum, see it is the full cone and we have cut it from the center somewhere with a plane parallel to the base. Then this lower part is the frustum. Suppose the radii of this are R1 and R2 and the height of the frustum is small h and that of the large, that is complete cone, is suppose capital H. The slant height of the curve is L and that of the frustum is small l. Then how to find out the curved surface area? What is the meaning of the curved surface area? See, this is the frustum and you can see this is the curved surface area we have to find. Suppose we join it, this is the complete cone you can see. If we find the curved surface area of this complete cone and then subtract the curved surface area of this cone, will be there we find that this is the curved surface area of this particular frustum. So we can write here, to find the curved surface area, frustum of cone, curved surface area of the frustum of cone will be the curved surface area of the total cone minus the curved surface area of the upper part of the cone. To find that, first of all we have to find out the relation between capital H, small l, capital H, small h and all. Here we find this is a right angle and this is also a right angle. Can we say that this complete triangle OCB and triangle OFE are similar to each other? So we can write here triangle OCB is similar to triangle OFE. We know that in the similar triangles the ratio of the corresponding sides are equal. So can we say here that OC upon OF is equal to OB upon OE, and also this is BC upon EF. What is OC? You can see OC is capital H. What is OF? OF is H minus H. What is OB? OB is capital L. What is OE? OE is L minus L. What is BC? That is R1. And what is EF? That is R2. If we take the first and the third part, what we find? That H upon H minus H is equal to R1 upon R2. If we cross multiply, we are getting HR2 is equal to HR1 minus HR1. By transposing, what we get? We can get HR1 is equal to HR1 minus HR2. If we take H common, this will be H into R1 minus R2. Similarly, from the second and third, what we get? L upon L minus L is equal to R minus R2. And from this also similar way we will get LR1 is equal to capital L into R1 minus R2. After getting these relations, suppose they are 1 and 2, we can find the curved surface area of frustum is equal to curved surface area of large cone minus curved surface area of small cone. What is the curved surface area of the large cone? That is pi into R1 into L minus curved surface area of the small cone, that is pi into, in place of R, this is R2, that is the radius of it, and the slant height of this is L minus L. Simplifying this, we will be getting here pi R1L minus pi R2L plus pi R2 small l. If we take pi L common from this, this will be pi into L into R1 minus R2 plus pi R2L. We know that L into R1 minus R2 is equal to LR1. So we can write this as pi into LR1 plus pi into R2 into L. If we take pi common and also L common, will it be pi into R1 plus R2 into L or not? So this becomes the formula to find out the curved surface area of a frustum. Now in case it is a solid frustum, and you want to find out the total surface area of frustum. What we will do? We are getting two more faces, they are circular faces. We have to add the area of these faces also. So this will be equal to pi into R1 plus R2 into L, that is the curved surface area, plus area of base, that is pi R1 square, plus area of top, that is pi R2 square. This becomes the formula to find out the total surface area of a frustum. Now to find out the volume of a frustum of a cone, what we will do? We will do the same thing here. We will find the volume of the complete cone, and if we subtract the volume of the upper part of the cone which has been cut from it, then will that give us the volume of the frustum? This part is to be same because we have to find out the relation between small h and capital H. We have already completed it. After that we find the volume, so we can write volume of frustum is equal to volume of large cone minus volume of small cone. What is the volume of large cone? The volume of the large cone is 1 by 3 pi into R1 square into capital H minus volume of the smaller cone, that will be 1 by 3 into pi into R2 square because the radius is R2 into, in place of H, this will be H minus H or not. If we take 1 by 3 pi common, we will have here R1 square H minus R2 square H and plus this will be R2 square small h or not. What we can get from here? This is 1 by 3 pi into, is it R1 square minus R2 square, which can be written as R1 plus R2 into R1 minus R2 into H plus R2 square into small h. And we have seen here that h into R1 minus R2 is HR1. So can we get here 1 by 3 pi into R1 plus R2 into R1 into H plus R2 square into H. If we take this H also common, will it give us 1 by 3 pi into R1 into R1, that is R1 square, plus R1 into R2 plus R2 square into H. This is the volume of the frustum. So volume of the frustum can be obtained by 1 by 3 into pi into R1 square plus R1 into R2 plus R2 square into H, that is the height of the frustum. Now after learning about the concept, we will discuss some of the examples where these formulae can be applied. See here, the first example is the radii of the ends of a bucket are 20 centimeter and 8 centimeters respectively. If its height is 35 centimeter, find how many liters of water can be contained in it. See, water contained means we have to find out the volume of the bucket which is in the form of a frustum. Here we are given that the radius of the top R1 is 20 centimeter because we know the bucket is open from the top and the top is larger in the radius. The radius of the base R2 is 8 centimeter and the height is 35 centimeter. We know the formula of finding the volume of the frustum. So we'll write the formula: volume of bucket, that is a frustum, is equal to 1 by 3 pi into R1 square plus R1 into R2 plus R2 square into H. And we substitute the values. This is 1 by 3 into 22 by 7 into R1 square, that is 20 square, R1 into R2, that is 20 into 8, plus R2 square, that is 8 square, into H, that is 35. We can cancel this 7, 5 ja 35, and we get 22 into 5 is 110. So this is equal to 110 upon 3 into 400 plus 20 into 8, 160 plus 64. This is equal to 110 by 3 into 400 plus 160, 560 plus 64, that is 624. If we cancel it by 3, 3 2 ja 6, 3 8 ja 24. And when we multiply, this gives us 0, 88, 22. This is 22880 centimeter cube. And we have already learned that 1000 centimeter cube is equal to 1 liter. So we can write therefore quantity of water contained will be equal to 22880 upon 1000. This cancels and this is 22.88 liters. So we could find out that 22.88 liters of water can be contained in that particular bucket. The next example we have, the radii of the ends of solid frustum of cone are 33 centimeter and 27 centimeters respectively, and its height is 8 centimeter. Find its total surface area. What is given here for the solution? We see we have been given the radius R1 is 33 centimeter, R2 is 27 centimeter, and the height has been given as 8 centimeter. To find the total surface area, first of all, we have to find out its slant height. So we can write slant height L is equal to, we know the formula, that is R1 minus R2 square plus H square. Will that be equal to root of 33 minus 27 square plus H square means 8 square? Is it 33 minus 27, 6? Square of 6 is 36 plus square of 8 is 64, that is root of 100, or we can say 10 centimeter. After finding the slant height, we can make use of the formula of the total surface area. We can write total surface area of frustum, that is pi into R1 plus R2 into L. This is the curved surface area, plus the areas of two circular faces, that is pi R1 square plus pi R2 square. If we want, we can take pi common. This is pi into R1 plus R2 into L plus R1 square plus R2 square. Substituting the values, we get here 22 by 7, R1 plus R2, this is 33 plus 27 into L, that is 10, plus R1 square, that is 33 square, R2 square, that is 27 square. Simplifying this, we get 22 by 7 into 33 plus 27 is 60 into 10, that is 600. Square of 33, that is 1089, plus square of 27, that is 729. Is it 22 by 7 into, when we add them all, 2418. This is equal to 53196 upon 7 centimeter square. So we could find out the total surface area here. The only thing is, in such question we have to see whether slant height is given or not. If not given, we have to find out the slant height first, and then we can find out the total surface area. In the next video, we will be learning how to find out the curved surface area, total surface area, and volume of the combined solids. Suppose two or more solids are combined together, and then we have to find out the different areas and volume of them. Thanks for watching my video. If you have any comments or doubts, Leave them in the comment box and I will get back to you.